Alright, today we're going to be looking at chemistry. So, under this chemistry, we're looking at something that is very vital. In order for us to understand chemistry, we have to know how chemistry came about. How chemistry came about. What is the smallest unit that made up all these talks about elements, about these their characteristics, and all of that? So, in this video, you are going to be understanding everything you need to know about atoms, elements, molecules, and lot much more. You are going to be understanding the technique in which these atoms behave. You are going to be understanding the technology behind atoms in this video. So today we're going to be looking at, let's start with atoms. Let's start with the definition for atoms. I'm going to be saying the definition. An atom can be defined normally in previous times they were defining atom as the smallest particle of an element. But new research shows that, modern research shows that an atom cannot be defined as the smallest particle of an element. Why? Because during a radioactive reaction, an atom can be split into simpler units. So we cannot say an atom is the smallest particle of an element because modern research shows that atoms they can be split into simpler units, and because of this, we cannot call atoms smallest unit of elements. So we can say atoms are small units of elements, not the smallest unit of elements. They are small units of elements. They are small units of elements that can ever exist and still retain the chemical properties of that element. That is the definition for atoms. They are the small units of elements that can ever exist and still retain the chemical properties of that element, meaning that without atoms, we have no elements. And there are some things that make up an atom. There are some things that make up an atom, which I'll be talking about briefly. So first of all, now we have looked at the definition of atoms. They say they make up an element. They are small units that make up an element, or they can ever exist and still retain the chemical properties of that element. Now, we know that atoms they have a form in which they exist. Now, I will give us a simple atomic structure. Let's look at a simple atomic structure. Okay, here. Okay. Okay. Okay, now this is a simple atomic structure. Now, from this atomic structure, we'll find out that we have on the outermost part this circular thing you can see, and we have on the innermost part this place I shaded. Now, this place you can see can be defined as an orbital. This is an orbital. The outermost part of an atom is known as the atomic orbital. Some textbook will call it the atomic orbital. And now, how should we define an atomic orbital? An atomic orbital can be defined as a region of space in which there is a very high probability of finding an electron. An atomic orbital can be defined as a region of space in which there is a very high probability of finding an electron. And now you will take note that this is an electron. So we can say that this is the atom for hydrogen, of hydrogen. This is the atomic structure for hydrogen because hydrogen has the atomic number of just 1. And you notice that we have just 1 electron there. And we'll notice that the atomic number can be defined as the number of electrons on that atomic orbital. Now you take note that this is the atomic orbital in which there's a high probability of finding an electron. There's a region of space in which there's a high probability of finding an electron. And now this is an electron. Now because it's just 1 electron, we can say that this is a hydrogen orbital. The reason why in chemistry you take note that each time we are talking of anything regarding atoms, regarding atomic structure, we make use of hydrogen as an example is the fact that hydrogen has just one atomic orbital, and so it's very easy to draft out the atomic orbital and just write one electron. It's very easy than you using something like calcium, using something like chlorine, because the electrons on the outermost shell, they are much, and so it will make things a little bit rowdy. So we want a simplified version, and so we'll go for this. So now we have described the atomic orbital, a region of space in which there is a high probability of finding an electron, and this is an electron. Now this innermost part that I shaded is very vital for an electron. It's very vital for an atom. That is the life of the atom. Once you pull this place out, the atom does not exist again. It does not have life. And this place is known as the nucleus. Now you notice I labeled this nucleus. And inside that nucleus, you find the proton and you find the neutron. Now we need to take note of many things. Now they carry charges. Each of them carries their own charge. Now the electron has this electron, call it E dash. They have a negative charge. Now the proton P, I'll use P here to make it easier. Many textbooks, they don't use P. It has a positive charge. And the neutron N, has a neutral charge, meaning that it is it's just neutral. When we say that it's neutral, it does not have any charge, no charge, meaning that the neutron is neither positive nor negative. Now what happens because of this? Now we notice that the electron is negatively charged and the proton is positively charged. And we know that according to the laws of physics, both charges they attract. So positive is always attracted to negative charge. So there's a force of attraction between the electron here and the proton inside here. There's a force of attraction between the electron here and the proton inside here. And that force of attraction is what determines, they call it the electromagnetic force of attraction. And that is what determines the energy level of the electron. You'll notice that when you start looking at Niels Bohr's model of the atom, notice that the further away the electron is from the atom, the higher the energy level of the electron. But now you notice that for this hydrogen atom, the electron is very close to the nucleus, and so the energy level is very low. It's at a minimal point, very low. It's very low. Now, because the force of attraction is not really between the nucleus, it's between the proton inside the nucleus. And that's why they say the closer an electron is to the nucleus, the lower the energy level. It's at its ground state, meaning the energy level is low. It is at its ground state. And so this is a simple atomic structure. I just wanted us to understand how atoms they behave. So later we are going to be looking at some calculations. This thing has a very good calculation, how it contributes to the mass number. When we start doing isotopy later on, we'll look at how this thing contributes to the mass number when we look at isotopy. But now we have looked at atoms. Now let's enter the next channel. Elements. Now I defined atom as the small unit of an element that can ever exist and still retain the chemical properties of that element. Now what are elements? Elements are substances that cannot be split into simpler units or forms by ordinary chemical reactions. Now listen to the statement. Elements are substances that cannot be split into simpler units by ordinary chemical reactions, meaning that elements can be split, but we cannot use ordinary chemical reactions in the lab. We cannot use our normal laboratory experiment to split elements, meaning that they have a possibility of being split, but we cannot use our normal chemical experiment we do in our normal lab. We have to use a very spontaneous reaction, a reaction that occurs with explosive nature. And that kind of reaction is known as radioactivity. Later when we do radioactivity, we'll see how they are being split. You'll see the formation of all these things. So elements are classified into three major groups. we have the metals. When we are looking at group of elements, we'll take note of that. When we are looking at group 1 element, they are metals. Okay, we have non-metals. We have non-metals. And another type of element we have semi-metals. Semi-metals. And these semi-metals are also known as metalloids. Metalloids. They behave like metals and also behave like non-metals. So these are the three classification of elements. Now, for an element to exist, atom needs to exist. For an element to exist, atoms, they need to exist. So for element to exist, atoms need to exist. And that is where this term comes in. That is where this term comes in. First of all, let's look at the definition of molecules. Let's look at the definition of molecules. Molecules. I will give you a very simple definition of these molecules. Molecules exist within elements, but for molecules to exist, we need to have atoms also. So you notice that atoms, they become the building block for everything. Atoms become the building block for molecules. Then molecules become the building block for elements or compounds. We'll be looking at compounds soon. Okay, now look at molecules. What are molecules? Molecules can be defined as substance formed when two or more atoms combine. Molecules can be defined as substance that exist when two or more or are formed when two or more atoms they combine chemically, and this combination process is always chemical. And because of that, we have different types of molecules. So first of all, we need to know what happens for this thing to. We need to know the number of elements, the number of atoms, that are contained within molecules. We need to know the number of atoms that are contained within molecules, which is very vital. And for us to know that, we need to take note of this term, atomicity. Now, what does atomicity talk about? Atomicity talks about the number of atoms that exist in a molecule. The number of atoms that exist in a molecule or a compound is known as atomicity. Atomicity can be defined as the number of atoms that exist in a molecule or a compound. Okay, let's look at the oxygen molecule. This is the oxygen molecule, O2. Yes, this is oxygen. This is the oxygen molecule. Now, looking at this oxygen molecule, how many atoms exist within it? We have 2 atoms. Now, what is they will now ask you, what is the atomicity of an oxygen molecule? The atomicity there is equal to 2. The atomicity there is equal to what? Is equal to 2. What about if we have this one? We have calcium, Ca. This is a calcium molecule, or we call it calcium atom. Or I'll call it calcium molecule. It's also a molecule. Now, how many atoms are there? Just 1 atom. So we can say the atomicity is equal to 1. So the atomicity there describes the number of atoms that exist within a molecule. So let's look at a compound. Let's look at the definition of a compound. Now, what is a compound? A compound can be defined as a substance formed when 2 or more atoms of 2 or more elements, or a compound can be defined as a substance formed when 2 or more atoms of the same or different elements. Use this statement, it's very interesting. A compound can be defined as a substance formed when 2 or more atoms of the same or different elements are chemically combined together, and they can only be separated by chemical means. I repeat again, a compound can be defined as a substance formed when 2 or more atoms of the same or different elements are chemically combined together, and they can only be separated through chemical means. Now, you take note that during a chemical reaction, what engages in that chemical reaction cannot be defined as the element or the compound. we can say that the atoms of those elements are the ones doing the chemical reaction. And because of that, they begin to interchange places to form a compound. Let me give a simple explanation without too much talk. Let me give a simple explanation without too much talk. Let us say magnesium. Okay, magnesium, which is solid in nature, is reacting with oxygen. Okay, reacting with oxygen. Oxygen is gaseous in nature, which is O2. So magnesium will react with oxygen to form something like this. Now, magnesium will become Mg. So change of radical will become Mg. Okay, if I'm not mistaken. So first of all, MgO. So this will be the substance that is formed. Now what happened? The atoms, they interchange position and now they have united. And this unity is what formed this. Is what formed this compound. This unity is what formed this compound. Not just Mg, okay? So we have Mg2. We have Mg2O2 if I'm not mistaken. Mg2O2 if I'm not mistaken. So what formed this compound? What formed this compound? Do you know why it's MgO2? Okay, now we want to look at the atomic number of magnesium and want to look at the atomic number of oxygen. So there's a particular phrase they normally use. He has light brain but could neither offer. He has light brain but could neither offer. You notice that oxygen has an atomic number of 8. I'm not going into details. I just want to show you how this substance was formed. So oxygen has an atomic number of 8. Okay, so let us draw the atomic structure. So we notice at the ground state we start with what? 2 electrons. 2 electrons. Now for the atomos shell, now we have put 2 electrons. How many electrons do you think remain? 6 to complete 8. So we count electrons like this before pairing them according to Pauli's exclusion principle. 3, 4, 5, 6. But you notice that this atom is not stable. Why is it not stable? Because now we need 2 electrons to complete this guy. So oxygen requires 2 electrons to complete it. Oxygen requires 2 electrons to complete it. Are you seeing it? So here is blank, here is blank. So let's go to magnesium. You see the technology there. Now let's look at where magnesium will fall. He has light brain but could neither offer full 9 subjects. So that is 11 mass cap. So magnesium falls at 12. Magnesium is equivalent to 12. Let's go. Let's draw the atomic structure for magnesium. So we start with 2 electrons. The next guy will occupy 8. 1, 2, 3, 4, 5, 6, 7, 8. So that is 10. Abi? So now the next guy will remain 2. 1, 2. Is that not 12? Look at it. Now, this guy has a possibility to give. What will make this one stable? It has to give out these 2 so that 8 will be left. This one has to receive 2 to complete 8. This one has to give out these 2 in the outermost shell. The 2 valence electrons. The electrons at the outermost shell of an atom is known as the valence electrons. It has to give out these 2 valence electrons so that it will have just 8. It will be stable. Why these 2 has to receive the 2 to become 8. So what will happen? This guy will give this one 2. This guy will give this one the 2. So what will happen? This one will complete 8. And in chemistry, when you are receiving, you become negative. How many did this guy receive? 2. So oxygen will become 2 minus. You see it? They say give us, receive as the one receiving and the one at the bottom. So him receiving the 2 becomes negative. But magnesium giving out the 2, magnesium becomes positive. Mg 2 plus. Now what happened in this equation? So we have magnesium reacting with oxygen with O2. Oxygen is O2, equivalent to this. so what will happen? So what will happen? There will be change of radical. We know that this is 2 minus this is what? So it will become Mg. The 2 here will come to the. So we know that this is 2 minus. We know that this is 2 plus. Normally they don't show it in the equation. They just write the equation for you to see. This is what happened. So there will be a change of radical. This one will collect the 2, Mg2. The oxygen will collect the 2, O2. Okay. And what will happen? This equation now is not balanced. You notice that to balance this equation, magnesium is 1 here, oxygen is 2 here, oxygen is 2 here. So you notice that the oxygen atom is balanced. So let's balance this equation. So first of all, we need to look at the one that is not balanced. Magnesium here is 1, magnesium here is 2. So it's not balanced. We want it to be equal at both sides of the equation. So this is to make it equal, we have to put 2 at the front of the magnesium here. So now you notice that we have 2 magnesium plus O2 giving us this Mg2O2. So now the equation is balanced. 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen. Now we have successfully balanced the equation. I had to show this one. This is not what we are really looking at. We are looking at the atomic structure and we came to compound. So this guy formed now is a what? It's a compound. Due to what? The combination of the magnesium atom and the oxygen atom. Now go back to the definition. A compound can be defined as a substance formed when 2 or more atoms of the same or different elements. Now 2 atoms of different elements combine to form this compound. The atoms of magnesium and the atoms of oxygen combine to form this compound. That was just the technology I wanted to show you. So now we'll be able to look at what a compound is and everything that a compound is. Now let's come over here. Let's look at the types of a compound. Or let's look at So now we have this mono, okay? Sorry, let's look at types of molecules, not types of compound, types of molecules. Types of molecules. Remember, I gave a definition of molecules, that molecules are substances formed with 2 or more atoms. They combine together. Now, for this to happen, that is what gave rise to atomicity, the number of atoms within a molecule. So now, we'll now look at types of molecule, monoatomic molecules. Monoatomic molecules can be defined as molecules consisting of just 1 atom. For example, we have calcium. Calcium has 1 atom. We have magnesium. Magnesium has 1 atom. So these guys are known as monoatomic molecules because it's just 1. You are not seeing anything like 2 under subscript 2. Now let's look at this other one, the atomic molecules. The atomic, anytime you hear the word di, it's 2. The atomic molecules. The atomic molecules can be defined as molecules that consist of 2 atoms. For example, the oxygen molecule consists of 2 atoms. Okay, the hydrogen molecule, because it's gaseous in nature, consists of 2 atoms, and lot more. Because of time, I'm not going to go into that, but later on we shall be looking at many different things. So this is it. And we also have polyatomic molecules. Polyatomic molecules. So polyatomic molecules can be defined as molecules that consist of 3 or more atoms. And a very typical example, you don't even need to think much, is ozone, known as O3. Ozone consists of 3 atoms, so it's known as a polyatomic molecules. And because of this, we cannot draft out a table. Let's look at something. Compound, okay. Atomicity, compound atomicity. Okay, let's look at this one. Let's look at this first compound. This first compound, I'll pick water, H2O. Now, what is the atomicity of this compound? How many atoms are there inside this compound? We have 2 hydrogen atoms and 1 oxygen atom. So the atomicity becomes what? 3. Now, let's look at H2O2, hydrogen peroxide. Now, we have 2 hydrogen atom and we have 2 oxygen atom. So that will become what? 4. Okay, let's pick this one. H2SO4 tetraoxosulfate 6 acid. So we have 2 hydrogen atom, 1 sulfur atom and 4 oxygen atom. So that is 3 plus 4, that is 7. Okay, let's look at this one. NH3 ammonia. So we have 1 nitrogen atom and 3 hydrogen atoms, and that becomes 4. There are more. So I've taught you how to find the atomicity of a compound. Now we have learned a lot on this video. I promise you in this video you understand the basics for atoms, for molecules, for compounds. Now, and types of molecules will tell you that the atomics, the number of atoms in that molecules will determine the name you will give to that molecule. For monoatomic, they just have 1 atom. The atomic, they have 2 atoms. So now looking at this compound or molecule, we can call them compound or molecules because they are combined, they are atoms combined. So looking at it now, you notice that there is something. This is a polyatomic compound or molecule. This is polyatomic. All of them here are polyatomic. All of them here are polyatomic. All of them here are polyatomic. So this is just what I wanted to touch. Another thing we'll be looking at is mixture, but I'm not going into that. But let me give you a definition for mixture. Mixture can be defined as the physical combination of 2 or more components. Physical combination of 2 or more components, and it can be separated by physical means. That is where separation technique came in. It can be separated by physical means. Now let us see you mix many sands with a magnet, with iron. In order for you to separate them, we use what they call magnets to separate them. We use what they call magnets. So these are substances that can be separated by normal physical means. So you can go and do research on mixtures. You notice that some mixtures are homogeneous and some are heterogeneous. So those are the research you go and do. But at the end of this video, I'll be able to explain the meaning of atoms, the atomicity, and so much. I hope you learned a lot from this video. So in our next video, we are going to go into details about atoms, into more details about the atomic structure and how we can solve out work examples there. We are going to work out some examples on these atoms. We are going to work out some examples, very good examples on them, to see how deeper we can go. So this is the basics and fundamental knowledge that every chemistry student has to have in order to understand chemistry very well and effectively. Thank you.